Space Center has known for its small satellite engineering philosophy in the past 3 to 4 decades. This is extremely important to the space domain, and because that would make space more accessible, because we can make space system smaller, lighter, and lower cost. So our aim here today is to test and demonstrate some micro-rover technologies that we envisage to use in future planetary missions, including to planets like the Moon and Mars.
So we've got the locomotion system, which consists of wheels and motors that drive these wheels. We have 4 motors that independently drive each wheel. We also have a sensor on each motor to allow us to sense the motion of the motor, the behavior of the motor. We have a suspension that allows us to keep the whole vehicle stable when it is negotiating obstacles. We have an enclosure that contains our electronics. The enclosure includes a onboard computer, microcontrollers that control the locomotion. We have a few cameras on board. There's an overhead camera pointing downwards, and we also have a pan-tilt camera at the front.
So in the control room, although the rover itself can drive autonomously, we want to actually see what's going on inside. So we're collecting data such as the image data and the other sensors on board. So the point of the control room is to be as passive as possible. We want the rover to do as much of it by itself, but we need to collect the data. We want to be watching that things aren't blowing up inside as well, but they're not. So this is the onboard camera, and we're watching the terrain in front of it, so that in the future we can do visual odometry, so we can track its movement via the images that we're using. It's been a wonderful opportunity. The weather's been brilliant, and everything's been working perfectly.
We are very pleased with the outcome of the field trial. I think we have met all the goals that we set for the field trial. We have successfully tested and demonstrated a range of technologies we have developed on the micro rover platform.